Hello and welcome to today's presentation, Data Masking in the Age of GDPR. I'm looking forward to walking you through the topic of data masking in the presentation today. I look forward working with you. My name is Bernd Baier. I'm a Senior Solution Architect with Libelle. I'm joined by Vamsi Malabarapu. He's also a Senior Technical Consultant. He's also our Service Delivery Manager, and he's going to go show some of the live demonstration in the second part of the presentation. So some of the highlights of the presentation today, we're going to talk about the GDPR very briefly, because data masking is really only covering, or data masking is only a piece of the puzzle when it comes to GDPR. So there's an overlap, GDPR and data masking, but each topic stands for itself. I want to separate the terms encryption, obfuscation, scrambling, anonymization, and masking, and then just do a better definition. We want to talk about how to use SAP's data dictionary, identify the sensitive data heights, that's the data explorer, defining masking profile and masking procedures, how we ensure integrity of the masked data, and then the dynamic masking versus persistent masking, the execution, how we can accelerate that, and then look at the live tool demonstration. Quick introduction. Libelle has been founded in Stuttgart, Germany. Vamsi and I are both working in our US office with our teams, and we have offices also in Paris, France. And we have been working in the enterprise market since the mid-90s, developing, marketing, and selling enterprise software. We have more than 1,500 installations and more than 400 corporate customers worldwide. We have a total of 8 of the global Fortune 50 customers as our customers. We work with very large organizations. We work with mid-sized companies. So basically everybody running SAP is a potential customer for us. Our solution portfolio, we have 3 main divisions. We have a data replication division where we provide database replication for the different platforms, mostly around SAP, but also non-SAP, ProgressDB, MySQL. And most of the data replication is in the area of disaster recovery and specifically cloud migration into the cloud or out of the cloud or between clouds. It's something we do very actively. We have an area of system refresh automation where we provide a couple of key tools, System Copy, which is automating the homogeneous system refresh. We have an add-on for client copies, and then we have an add-on for data masking, which can either run as a standalone or as an integration into the system copy workflow. But even if it's called an add-on, it's always a standalone implementation that can then interface into the system copy workflow. We have 2 more solutions on the right-hand side. Libelle DataMasking is an IDOC monitoring solution. It's very helpful if you have a lot of IDOCs and IDOC issues to provide a better user interface for the end users and for the administrators. And Submon is an SAP monitoring tool that helps automating the monitoring of critical transactions. So let's talk about GDPR quick. And interestingly, it's one of the big drivers for data masking projects where customers say, now we have GDPR, we have a European entity, and now we need to do data masking. GDPR and data masking, as I mentioned in the beginning, really each topic stands for itself. GDPR is a European legislation that requires that private information needs to be kept confidential and safe and give end users certain rights to access that. But data masking is not really GDPR is not the only driver. It just so happened bubbles up to the top. There are so many other legislation and drivers for data masking. So GDPR is just the one that is currently the most discussed. So what it specifically says, we have to identify personal data. We have to identify who owns the data and who has access to the data and what we need to do in terms of a breach. And basically each company, again, it's the driver for data masking. If you store data on European citizens, you kind of should comply with and there are penalties for non-compliance. I don't know how they're ever going to go after US entities if they don't have an entity in Europe specifically, but I think similar legislation might come to the United States. But either way, personal data is really only one area of data that is sensitive, that needs to be protected. There's so much other data like financial information, email addresses, as simple as that, contact information, account information. So GDPR is really only one topic of a massive drive for better information security. During the 2 years we now do the data masking projects, we have different people, different organizations have a different understanding of what we mean with data masking, what they mean with data masking. So I try to clean up the terminology. So when we talk about data masking, we mean data obfuscation or data scrambling. And the point is really we want to replace original data with random data that remains usable for testing. So we don't retain original data. It cannot be reversed unless you intentionally go back and trace the masking workflow. And it is human readable. So if there's a name called Miller, we make a Smith after it. And the point is we want to make sure it's unidentifiable after the masking completed. Now, the data masking from Libelle falls in the same category of what SAP offers as a data masking option or data obfuscation option in TDMS, where you just replace real data with random data, or companies are writing scripts that they do a system refresh, and then they have a couple of scripts which are replacing names or social security numbers after the system refresh that they are not available in the test system. Data hiding. So SAP, and it's available in other data masking solutions as well. Data hiding is really the concept where you keep the original data in your database, but you restrict access to the same data. And SAP HANA is now using the term data masking exactly in that context. So you provide a limited access to the database for the user on a database level. So the original data is still there, but they provide some kind of a shadow table where users see a different view of the actual data. They use data masking. I like to use the term data hiding because it would be more accurate because the data is still there. Data encryption is the standard encryption of data at rest in text. It's not human readable, but I think everybody knows what we mean with encryption, but often it comes in the same category of terms when you talk data masking. That's why I include it. Data anonymization is, from our perspective, somewhat data masking, but as we looked into the definitions of data anonymization, it's usually narrowly focused around personally identifiable information. And it's also often meant as a sanitation that the data is simply overwritten with constants or with a blank, but it falls there's an overlap between data masking and data anonymization. And there's another term we found in that context, the data pseudonymization, that it's kind of a little bit of data masking, a little bit of anonymization, but you define certain tokens for people that they are still the original people, but you give them a kind of a certain name. You can do data pseudonymization with a data masking, simply defining how you replace the values, but that's a term we also found out in the market for data masking. So Libelle is data masking. We don't retain original data. We go in the database, physically replace real data with random data that follows certain values and certain structures. So I read out the definition a couple of times, but just for a matter of completeness. So we want to hide original data. I probably have to update because now we talk about data hiding, but of replacing original data with random characters of data. We want to protect the data, but at the same time, we want to make sure data remains usable for the purpose of testing. And data needs to look real and consistent, not only for looks, but also for consistency. If you have a program that processes credit card information and you have it in the test system, those credit card numbers need to make sense. Otherwise, the programs potentially fail. And then I mentioned GDPR, some of the other drivers. Very in the medical industry, you have the HIPAA requirements, you have hospitals storing patient data. There's ITAR requirements where you have sensitive government-related information, and you need to make sure only specific people have specific access to specific data. Non-compliance penalties are very high, and then I think also the public impact. It can destroy companies if there's a major data breach and data gets downloaded and spread, and it becomes public, which it has to become public at this point because you have to notify the regulatory bodies on breaches. It's very risky. And if you think about, we're talking about non-production SAP systems in our context, and they are exact replica of production. And if you are DBA, you know that you can do a simple export on some of the key tables, and you basically have all the information you need. So it's much easier than a lot of people think if you have access to the right system at the right permission level. And this is exactly the example, and this is for me the main driver for why we need data masking. Each SAP production system has 2, 3, 5 replicas of the same, and usually there are lower security policies. You have external developers. You have a large number of people working on non-production system, and people don't pay enough attention to who accesses those production systems. Also on a test system, you might get root access, which you would never get on a production system. So it's really, really dangerous to keep all the sensitive data in the non-production system as they are replicas of production. So Libelle developed this tool called Libelle DataMasking. It's a solution. I like to call it solution better than tool. And it came out of our Libelle system copy practice, where customers initially said, I want to run a script that replaces certain HR data. And that's how we started to think about how can we make a real data masking solution out of it instead of having a collection of scripts. So we built this on the new Libelle platform. It's a application server. It's our own version of SAP NetWeaver. We call it the Libelle platform. It's very massive. It has LDAP integration. It has its own internal database in order to manage the data masking algorithms and executions, all the connections to the different databases. So Libelle DataMasking itself has the task of masking non-production data according to predefined rules. And the idea is you set it up once, you test it once, and then you just execute it over and over with the same results. Some of the key components is we want to provide real names for person or real data that looks as realistic as possible. So we saw customers writing scripts and they just replace every name with exactly the same name. That might work for some, but might not work for other because you need to have a certain selection of different names for it to make sense. Addresses need to be correct. We can recreate certain numbers if that is a requirement. Account numbers which have check digits, we can apply that in the algorithms, and then also credit card information. So overall, there are two main components in our software. There's a component of a masking profile and a component of a masking procedure. The profile is really the definition of tables, columns, and field names to say what is the sensitive data in SAP we need to mask. And that's where we really need help of the SAP customer, of the functional team, is what is the data in your database you consider as sensitive and which you want to mask. So we are working on having these default profiles. So we have names, for example, bank account numbers as a default profile out of the box, which either can be used or we just plug in the table names, which makes usually more sense. The procedure is really the algorithm that is applied to the procedure to say, what are we doing with the name? Are we using our reference database to recreate random names, or are we overriding data with a constant? If there's a description, for example, maybe we just want to completely remove the description and replace it with a constant. So these are the masking procedures, and they can be extended by the customer. overall, and I'm gonna get more into this consistency example, what we want to make sure is if we mask a name or if we mask a specific number, after the masking is completed, the same input number is always going to result in the same masked output number. And that helps to keep the integrity. Let's say you have names across multiple SAP systems. We can mask it in a way that we always keep the same output data. I have a more detailed explanation on how exactly we do that. Libelle DataMasking, or LDM, we see it, or it is a standard software. So it's not a collection of script, it's not a service, it is really a standard software that is installed on a LDM server. That LDM server is then configured to connect to the data stores, data sources we want to mask. And you set up the software. You then define the profiles, either by you giving us a list of fields, or we work together trying to identify those fields. Define the masking procedures, which are the algorithms. How should we mask the data? So again, should we replace names with constants? Should we replace names with our reference database? There's a piece called LDM Explorer, which is attempting to help identifying what is really sensitive in the SAP system. And it is a little bit complex because the SAP data model is extremely complex with, I think, hundreds of thousands of tables, or 100,000 tables at least. And on the other hand, SAP is very organized, so it has the data dictionary which stores information about those tables. So the LDM Explorer is querying the data dictionary and is trying to help us and help you find where could sensitive information hide. You only need to run the LDM Explorer really in the beginning. When we do the system refresh, step 1, 2, 3, 4, we don't really have to repeat unless we want to change the configuration. But that just simply helps us on the first masking run and hand over for the users to validation. After that, we're simply going to execute after the system refresh. And this is one of the examples I use in my projects to say, what do we need to mask? And this is often the critical question in a masking project, to say, now what is sensitive data? And if you ask different people have different expectations on what sensitive means. But we need to really nail it down to specific fields in the SAP data model, and that's often a challenge. So I like to contrast the data masking with the system refresh automation. If you do system copies, you have a production system, you got to copy it to QA system, and there are 200 steps you have to execute, and it's a specific list of items you need to do. It's very black and very white. It's very black and very white. It's done white or it's not done white, and you have specific parameters where you can determine if it's done white or not. Data masking, the technical execution is 100% black and white. There's an original field which needs to be masked, but the definition of what is sensitive, it's really up to the organization, and that's a big gray area, and that's usually where we need to spend some time upfront in the project to talk about what is sensitive, how do we identify the tables, and how do we identify the fields. So let's talk about the masking algorithms a little bit. From our perspective, again, the Libelle data masking server is built on a Libelle platform. So there's a lot of power and intelligence behind it. And we really spend a lot of time designing the solution, building the solution, and put thought into the foundation of the data masking solution. Now that has the advantage that it's going to be it is a very good fundament. But at the same time, when you look at what's built on the fundament, our front end has some design shortfalls. Currently, we're still working on the design because we really focus on a good foundation. So, but that's how we like to do things. We are thinking very long term and like to be generic when we implement functionality. So the components and that's why I got to the point, is the components for algorithm. We thought about how do we build the algorithms, and there are 3 key tables. There is the algorithms at the bottom. I start at the bottom. There is a reference database which contains names, which can contain addresses, which can contain anything you want to replace your data with that needs to be masked. And then we have this concept of a LDM number table. So when we start the masking run, every masking run requires the user to provide a masking key. It's kind of a passphrase, and based on that masking key, we are building a number table, which is hashed, which is SHE2 based, which is going to be fairly big. It's 6 megabytes. And this is somewhat of a lookup table we are building in order to provide the masking algorithm. And that's going to be very critical in order to execute the masking. And this is what it specifically does. So we do the masking, we provide, everything is configured, we got the fields, we got the algorithms defined, and now we want to run the masking. We provide a masking passphrase, which can be short, the longer the better because it's safer. And that masking passphrase is building a nummap bin specific to that passphrase. Different passphrases going to result in different nummap bin files. And each nummap bin file is unique in a way that each input value is going to reach exactly the same output value. Now, if you only have the same input, different input values, it doesn't really matter. But if you have the same name 10 times, every time we hit the name, we're going to hit the same output value because we base it on the nummap bin file. Now, names could be easy because they're usually not a key. But think about if you have a specific number, which reference is somewhat important because that account number shows up in another table at a later point. Same input number with the same passphrase, always going to lead to the same output number. So it's really neat in order to provide consistent results, even across different SAP systems. The masking run, this is now the technical execution of the masking workflow. We are masking directly on the database, and we got two options. We can mask directly on the original tables, or we can mask on shadow tables. That's what we usually do, specifically in the proof of concept when we mask for the very first time, that we mask on a shadow table and then replace the original tables with the masked data, which gives us a lot of options to accelerate the workflow. We have programs to read out cluster and pool tables, get information out, and then put them back in. So if there are cluster pool tables that needs to be masked, we have an upper program that unpacks and packs the master and pool tables back into that we can access them on a database level. So some of the descriptions in this slide are in German, but I want to give you an idea on how we do the algorithm. And again, we spend a lot of time thinking about algorithms, and then if you define the software in the right way and then have the algorithm as a specific place with defined input and defined output values, it gives you a lot of opportunities to fine-tune the process, change the algorithm, make it better. And in the past, this is, I think, the second or the third iteration of our algorithm, because sometimes we hit customers with some very, very, very large tables with hundreds of millions of rows, and then performance is critical. So we have changed that algorithm a couple of times or iterated in that algorithm to give you a good performance value. So in the beginning, we make a copy of the table, and then we add a small addition for our fields that we can keep track of what we masked. We do the anonymization. We remove the indices and the fields we added, and then we copy the data back to the ADRC and drop that shadow table. That is on the left-hand side if we work with shadow tables, or if we do work on the original table, it is similar, except we don't have to copy the data back to the original table. We have the option of running multiple masking threads at the same time. Again, we operate on the database, which alone by itself is giving it a lot of performance boost, because databases are extremely fast with things that databases are supposed to do. And when you think about what masking is hitting the database with updates. Now we do bulk updates, and we really try to send the update algorithm to the database in a way that the database can digest it fairly easy and can use built-in features of mass updates to really accelerate the process. So from our perspective, performance, we are really, really good, and we got values in some of our POCs of up to 100,000 rows, 100,000 updates per second in terms of masking, which is really fast. A couple of points on the data masking software architecture. So when you install the software, you install an LDM server. That LDM server has a couple of database and interestingly also file connectors. So we are then connecting to the respective database we want to mask. So we support everything you see on the screen. We can do other databases via ODBC. So if you have SAP, but you're also looking at some non-SAP applications, we can perfectly support that. And then again, we build this generically. We like to build things in a way that is universally applicable. We can also mask XML data, CSV data, and JSON data. I recently was involved in a proof of concept where customers receives JSON data from his European subsidiary, and they need to import that JSON data into their US SAP system. And the requirement was we want to mask the JSON data before they go into our US system, because we can't keep European personal data in our US SAP system. So that's something we do. And then from a different perspective, similar, it includes the browser front end. So this is HTML based. We are going a similar way SAP is going. So our system copy front end is Java based, and we are moving all our front ends long term to HTML. So data masking was built on an HTML interface. System copy was built on a Java interface, but it's all going to long term move to HTML. And you see the same if you look at SAP. There is HANA, there's the HANA Studio, and there is the HANA Cockpit. One is the newer platform, and one is the older Java interface. You can still do a little bit more in the Java than in the HTML, but everything is going towards the HTML interface. So the browser front end, you have the users, which are operating LDM, connecting, and then you do the masking on the respective dev, sandbox, and QAS system, similar to the screen you saw before, just from a SAP single landscape perspective. I put into my introduction the difference between ad hoc and dynamic masking, and this is a good point to talk about that briefly. When we do the masking, we do what's called an ad hoc masking. We do a system copy, and then we are done. When we are done with the system copy, we append the masking process afterwards. And there are also solutions which are somewhat a dynamic masking solution. From my perspective, the data hiding in SAP HANA is one of them, where data is masked dynamically, views are changed dynamically. And that's really only working if you keep the original data and can change the view dynamically. So this is really a big difference between ad hoc masking and the dynamic masking. We have two options to install data masking. The right-hand side central installation is our favorite. We would prefer to have one masking server and then update the changes on the respective system we want to mask. If you have to, and that's what we do in POCs, if you have two systems, we can do multiple LDM binaries. We are working on a solution where we can have worker agents that can sit on the masking on the respective system you want to mask to increase performance, but we are not there yet. Right now, we just do a remote connection, a standard database connection from the masking server to the respective system. So with that, I would like to pass the presenter role to Vamsi, and we would like to look at the software.
Thank you, Ben. So I hope you all can see my screen. I have here the LDM interface, the data masking interface. It's all browser-based, as Bernd explained earlier. And you see here, I have my agent installed on this particular host, LDM Aura w1.libelle.com, and it's running on port 9480. So basically the server is running, or the masking agent is running on this particular host, and it's listening on this specific port. You can define your own port. It doesn't have to be 9480. So, and then it waits for instructions about what data store it has to connect and what tables it has to mask and what fields it has to mask. So let me navigate through these different tiles. It's all web-based. As Bernd said, we are reworking on the design factor here. But by default, you will see the server where the agent is installed. So in this case, it's LDM Aura W1. If you want to orchestrate between multiple servers, you can keep on adding the agents, and then you can define your data stores and things like that. So it's still not completely defined yet, but that is the direction that we want to go. We want to have multiple agents talking with each other and doing the masking. And then our main advantage is what you see here. So here we have defined applications. Basically, we have two applications at this point defined. Bison is our test database for demo purposes. And then we have an ECC component. When we select this application, it's basically going ahead and selecting the appropriate profiles, which is what I would talk next. So we identify different profiles in the SAP based upon the domain and the element information. And we identify the table and field which match with the specific domain, and we classify it to a specific profile. As you see, we have provided out of box close to 70 different profiles, which would talk about account information, basically bank information, business partner profiles, credit card information, date of births, and address information, personal identification number like social security information, and email addresses and things like that. And these profiles are defined out of box. And then what we do is basically scan the database using the SAP data dictionary and identify all the tables and fields which require masking. Then how do we do masking is defined in the procedures. So again, out of box, we have all these procedures defined. We have close to 28 to 30 different procedures or algorithms that we call. And these procedures are then aligned to the profile that is identified. For example, if we have to go ahead and mask address, we go ahead and use this address anonymization procedure to mask address. Or for example, if we want to do date masking, we go ahead and do a date shift interval. Again, these procedures, we keep on expanding. We work with customers. We try to identify a specific requirement which is not identified in any of these algorithms. We go ahead and adjust or extend these algorithms. Basically, these are the base algorithms. And once we look at customer environment, look at the requirements, what tables and what fields need to be masked, depending upon the business validation, we might have to extend these profiles, which is fairly simple. On an average, we define anywhere between 5 to 8 algorithms for every single customer. And we keep extending these algorithm base here. And then we have something called references. References is basically to use what kind of data that we want to use to mask. So either you go ahead and provide a reference database or reference file, which is what the last two options are, where you provide first names and last name information to go ahead and take from those files to do the masking, or you ask Libelle to use Libelle's own database. We have our own database of first names, last names, address informations, emails. This is again country specific. So if we are, for example, trying to mask a French name, we go ahead and look at the French name database that we have, and we replace that name with a different French name. So we are trying to get data as close as possible to real data. but of course with a fake reference database that we have provided out of box. So we have name information, the first name, last names, then we have address information, we have emails. Again, this is basically the email domain. The way that we construct emails is basically taking the first name and last name @ the domain. And of course, the organizations, different companies, we just keep on scrambling it, and then the web addresses for those things. If you want to take the first names and last names that are already existing in your HR tables, we can take that reference details by selecting the first name and last name from the reference data. So once we have the references, alarming is again, if you want the tool to report any errors while you're not looking at the tool, you can just configure alarming here, and it will trigger an email saying that there was an error in the process, so that you don't have to babysit the tool basically. So it will write an email as soon as there are some errors in the tool. This is basically the different attributes and domains that we look at in the SAP system. And actions is for advanced use, where we try to tweak the algorithms or try to tweak the workflow or tweak the process of bulk updates and things like that. So this is for advanced usage. The key takeaways from this part is the profiles. We do provide out of box close to 75 to 80 different profiles, which will be matched with your SAP data dictionary, and all the tables and fields will be identified. And then procedures. These are basically the algorithms of how we are masking. Profiles is basically what we are masking. Procedure is how we are masking. And reference is basically the quality of the data that you want. If you want us to take Libelle provided reference database, if you want to take SAP internal reference database for first names and last names, or if you want to come up with your own list, you can provide that. So once we have identified the tools, then basically we go ahead and prepare the configuration. I already have a configuration here prepared. Basically, it's for SAP. And in the configuration, the important part would be the settings. This is where we define the system. Again, this is where the server is installed. And then the critical part in the configuration is the data store. This is where we define to what database we need to talk. As Bernd explained in the slides, we make an ODBC connection. In this case, we have our own connectors to talk with different databases. This is an Oracle database. We directly connect to a database using the schema user, and we read the tables, update the tables, and things like that. So, and by default, we have selected all the profiles that we have identified. So this is basically what information we are masking, and they are automatically aligned with the procedure on how the data will be masked. So let me quickly show you the results part, where you will be seeing the list of tables and fields that we have identified. So before we go into results, let me quickly walk you through the different phases. So we have 4 different phases here. We have a check phase where it will check the connections. It will check what profiles you have selected. It will check what kind of database you are masking. It will check whether the tool has the license to mask. And then we prepare. In the prepare phase, you could either let the tool do the work of finding out all the tables and fields. You could say, I would like to go ahead and provide my own tables. You could very much do that. Then we don't have to run these explorer phases. So if you have looked at the previous slides that Bernd showed, explorer phase is the phase which would run a scan on your SAP data dictionary, get all the tables and fields which match with the profile that you have selected. If you have selected all the 80 profiles, you're going to get a complete list of tables and fields, roughly around 1500 to 1700 tables. But if you're very selective, so let's say if you want to mask only address information, then the list of tables which will be much smaller. In my case, for this test run, we have selected all the profiles. So you would be seeing a complete list of tables and fields that match with the profile, and they are automatically associated with the respective algorithm. Again, this is completely optional. We normally recommend customers to come up with their list of tables, with their list of fields, and then we align them with a Libelle recommended algorithm. But if you think that the algorithm is not matching your requirements, then we are very much open to work with you and check with your business team to see what kind of validations are required, and we go ahead and change or develop a completely new algorithm. For example, if you talk about date of birth masking, that's a classic example. Most of the times we just go ahead and try to make the date of birth between 5 years and 80 years. But there might be some validations that you want to hit wherein you want the date of birth range to be only falling between a couple of years. So if you're born on 1990, you might want the date of birth between 1988 to 1992, plus or minus 2 years. So we go ahead and tweak the algorithm so that we can accommodate that kind of business logic. So the algorithms are highly customizable. And if you don't see any out-of-box algorithm, we always are willing to work with you and define new algorithms. And once we get the list of tables and fields, we basically go ahead and skip this Explorer part, because once we hit the Explorer, it's going to give a big list of tables and fields and associate them with the respective algorithm. And then this gem num tab, this is a very critical step. This is where we basically go ahead and generate a binary file, which will be used to generate keys out of the database. For example, if you have a name called Tom, we take the name Tom and do calculations using this binary file and come up with a name called Sam. And how we get this GenNum tab is basically depending upon the key that you enter into the tool when you prepare a new configuration. So when you're creating a new configuration, it will let you enter a number or alphanumeric string, which you can save for further masking if you want to have a same kind of masking happening on a different data store. So once we have the prepare phase done, then we hit the anonymize phase. This is where we do the pre-processing. Basically, we extract the data out, and then we perform anonymization and do some post-processing activities, which are basically if you want some kind of dependent tables to be changed as part of the main table that we are hitting. The classic example would be the info type 2 in HR, where we go ahead and update the first name and last name, but the dependent info type 01 has to be also updated. So, and the info type 1 has to be updated with the first character of first name and the complete last name, so that it's matching with info type 2. So those kind of dependencies can be achieved in the post-processing phase. And once we are done with post-processing, you basically go ahead and do your validations. And if you think the data, or if you see the data validations are successful, then you can finish the execution and you will see a report. Let me quickly walk you through the results part. This is where you see 3 different tabs. The Explorer tab is where we have list of all the tables and fields that the tool automatically identifies. As I said, I've selected all the profiles. Basically, it's going to do a complete SAP data dictionary scan and get me this list of tables and fields. So this is a huge list. And then it's going to automatically associate these tables and fields with respective algorithms. It's taking some time here to load the associator part, but basically you see the table and field, and then the attribute is country, and then it's going to go ahead and use an algorithm called anon location, and it's going to associate all the algorithms. But if you think you don't want to use this algorithm, you want to have a different algorithm, you can always go ahead and change these things. And then once we run the anonymization, I didn't run the anonymization here, But once we do the anonymization, this is where you would be seeing the results. The runtimes, as Bernd explained, it totally depends upon the performance that we get on the system. Typically, the LDM agent is doing a lot of bulk updates, so it requires high amount of CPU and memory. It reads a lot of tables, and we have seen performance ranging from 50,000 rows to 150,000 rows a second. So it all depends upon what kind of server is provisioned for running this agent and what kind of database we are dealing with. I think that should be it. Bernd, over to you.
Great. So let me pass the presenter role back to me. I have 2 more slides I want to show. So I missed one slide I wanted to show earlier, is the data masking in the context of automated system copies. So the data masking can be run 100% standalone without any system refresh automation solution from Libelle. But if you want to run it together, they would run basically side by side. Typically, you install the LDM master on the same server. You have the system copy master, depending on how much space you have left, but you don't need too much space unless you have hundreds of configurations. And then basically after the system copy completes in the post-processing, we do the imports, we do BDLS. You can trigger the data masking. There's a command line interface. And then you trigger the data masking directly out of the system copy, that you follow the workflow in system copy, and it triggers in the background the data masking. So I want to do a quick summary of what we looked at, and then we're going to be at the end of the presentation. We talked about GDPR in the beginning. Again, GDPR, data masking, they both stand by themselves. I do think the separation between the different terms are extremely important, because in an organization there are many people, many forces pulling in different directions. And then if we don't speak the same language, it's going to be difficult. So in terms of data masking, I think we have been very clear what category we fall under in terms of obfuscation. Vamsi spoke a bit about the data dictionary. That was good. I missed it on my slides a little bit. The definition of masking profiles and masking algorithms, ensuring the integrity of masked data. That is specifically the masking key, that we ensure the same outputs for the same input. I spoke a little bit about dynamic masking versus persistent. In this case, I use the term persistent, but I mean ad hoc, or you can use both terms. I think they're both right. How we can accelerate the execution, integration in the system copy, and we looked at the live tool demo. And with that, I want to encourage you to contact us for any questions. You can also reply to the email. I think that went from Jillian, who also works in sales and helps us in marketing and sales. Or you can contact Vamsi directly or me directly if you have any questions. With that, I want to thanks again for your attendance today, and hope everybody's having a good day. And I'm going to go ahead and close the call now. Thanks and goodbye.